Hello everyone. Sorry about the audio, but hello. My name is David Hanna, and today I'll be talking about enhancing VR, experiencing realism, and training simulations in a four-dimensional virtual world. So here's my design. It's not the best, but it's a design. So first, as we can see, I have the VR headset here. This is to simulate the vision aspect of it. And then here up top, I have the headphones, which simulate 3D sound. And then we see on the person's body, there's a motion capture suit. This is to tell the computer where the body parts are in real time. We also have here a circular 360-degree manual treadmill. This basically allows the trainee to move anywhere they want to without having to move in the real world. They just always go back to the center. We also have fluid pipes here for temperature simulation. So this goes directly with the motion capture suit. So the motion capture suit detects that some person in virtual reality, let's say, is next to a hot surface. Fluid circulates here around the entire body to simulate temperature change. So if they're going near a hot surface, it would send in a hot fluid, pretty much going to be water, so that it can simulate the feeling of the temperature. And if that person were to touch a cold surface, it would have cold water go through, simulating coldness. We also have here ropes that are coming off the person. These are for simulation of G-force, gravity, and weight. So the ropes down here, these are for weight in case that person's training for like the military or to be an astronaut. So these are to weigh that person down as if they were actually wearing the suit. Also for G-force, let's say that person is falling. These ropes just kind of, I guess, pull on the person, making it seem like they're falling. Or for gravity simulations where, let's say they're an astronaut in space, what it would do is that it would lift the person off, making them feel motion or weightless. And we also have here on the wall many different textures, and these would also go with the motion capture suit, where if that person were to touch a steel surface in the virtual reality, then in the real world the wall would rotate to the point where that person would touch the steel surface. And if they were about to touch a wooden surface, it would rotate so that the person would touch the wooden surface, and so on and so forth. Here we have the weighted benefit analysis table. The criteria are level of technology, the weight, cost effectiveness, and safety. For my individual criteria, I said that the level of technology is 10 because this is something, while it can be done today, the level of technology required is extremely high. I said the weight is a 3 because to me it's not the most important thing since it's going to be in only one place at a time. Yes, it will be sold to many different people, but it's not going to be sold to corporations where they are using it to train people, whether that be the military or doctors or astronauts or even for driving, so on and so forth. Cost also isn't really a big factor for me. It's going to cost a lot to make it, but to basically sell it, yes, it's going to cost a lot, but to me it's not a big deal. And then for effectiveness, I put it as a 10 because it needs to be as effective as possible to actually simulate real life events. And then safety I put as a 5 because it's already pretty safe, but it's not, it's basically like a best of both worlds. It is pretty safe enough, but it's not the safest thing in the world. And as a result, I got a total of 244. So yeah, this is my project about experiencing realism and training simulations in a four-dimensional virtual world.